experiment we have, right? Using law of cooling method of mixtures අපිට ඉලක්ක තියෙනවා, right? cooling තියෙන එකයි. Determination of specific heat capacity of a liquid. Specific heat capacity of a liquid. Then difference එක තේරෙනවනේ. Previous method was used to find specific heat capacity of a solid, right? Now to find the specific heat capacity of a liquid. Liquid using law of cooling. Right? Okay. පොතාම තව කට්ටින්නවා. ඔව්. ඔයාලට 30 minutes මදි නේද නෑනේ? 30. බත් ඇටේ ගනවද කොහෙද? හරි go. හරි මුලින්ම මේකේ theory එක බලමු. මේගොල්ලෝ අනිත් පැත්ත නේද? Right. Theory is this. Listen. Law of cooling no. Theory කියන්නේ law of cooling. Theory is law of cooling. Law of cooling කියන්නේ මොකද්ද? Law of cooling. What is law of cooling as a law? What is law of cooling? Q over T is proportional to theta minus theta. ඕකන් law එක. Right? Law is Q over T is proportional to theta minus theta. Right? Rate of heat loss from a heated object. Right? Rate of heat loss from a heated object is proportional to මේකනේ law එක. Rate of heat loss from a heated object is proportional to theta minus theta. Theta minus theta කියන්නේ මොකද? Excess temperature between environment and the body. Right? Body and the environment. හරිනේ? මේක තමයි law එක. law එකෙන් එන equation එක මේක. Right then හරිනේ? No, online scenario is different. ඕන time මදිනවද නෑ? Time හරිද 30 minutes මදිද? ඇතිනේ? Right. Law of cooling. QOD and rate of heat loss from a heated object is directly proportional to excess temperature between environment and body. Right? Body and environment. Right? Okay, making equation එකක් අපි ගන්නවා. Equation is Q over T is EA theta minus theta. Q over T is EA theta minus theta. මේක කෙනෙක් දාලා 30 minutes is more than enough කියලා. මම it's different කියලා. Yeah, it's true 30 minutes is more than enough තමයි. But it's different between online and physical, right? Online වුණා නම් 30 minutes කියලා කියන්නේ කාලා නිදාගෙන නැතිද ඉන්න උලා නේ විනාඩි 10ක් විතර නැප් එකකුත් දාලා ඉන්න උලා. Physical එකේ අමාරුයි. Right, listen. Agaro. listen, what are these terms? දැන් මේ theory එක මතක් කරගන්න ඕනේ. QOD, what is QOD? ඒක තමයි මම කිව්වා. What is QOD? QOD, rate of heat loss, right? Rate of heat loss. මම මෙතන introduce කරනවා rate of heat loss, right? E will know Q. What is E? What is E? 9 weeks. I'm දැනගෙන කියන්නේ නැහැ. What is E? Coefficient of emissivity. Coefficient of emissivity. Coefficient of emissivity. Right? Very much comparative to surface emissivity. What is A? Area open to atmosphere or area open to environment. Right? निकांग area के लिए बोला डन है. Area open to atmosphere. Right? Theta minus theta r is introduced as a single term. Excess temperature between body and atmosphere or body and environment. Right? Excess temperature. Right? Make a law of cooling. Right? Now when something cools in the environment, right? Heat is lost from the body according to this equation, law of cooling, and we had conditions of validity for law of cooling. Right? Then we make an experiment then everything is coming here. What are the conditions of validity of law of cooling? What are the conditions of validity? What are the two convection types we have? What are the two convection types? With respect to convection types, we have conditions. What are the convection types online? Convection types: natural convection and forced convection. Right? Under natural convection, what is the condition? Under natural convection, what is the condition? Only for small temperature differences. Right? Under forced convection, up until higher or larger differences. Again, 80 degrees Celsius under forced convection. Right? Under natural convection, it should be less than 20. Less than 20 values there. Right? Okay. What is a forced convection and a natural convection? What is a natural convection? Natural convection. By the way, what is convection? Then calling convection heat loss again. What is convection? Transfer of heat by decreasing density of a medium. Right? Convection by decreasing density of a medium. Right? Convection. For convection, we have two types now: natural and forced. What is natural convection? If a body, right, cooled under natural conditions. Natural conditions means, right, there cannot be any artificial wind blows. Right? Even if we can't blow to the system, right? Fans දාන්න බෑ. Natural wind flows හරන්න අනිත් වෙන කිසිම flow එකක් තියෙන්න බෑ. Right? Natural කියන flow එකක් uniform තියෙන්න ඕනේ. ඒක naturally වෙන්නේ නැහැනේ. Then to achieve natural conditions, it should be a controlled room if we are using this under natural conditions. Right? ඒක නිකන් control කරලාම තියෙන්න ඕනේ. නැත්නම් නිකන් තියන්න බෑ. Forced convections means, right? Forced. ඒක forcefully කරලා තියෙන්න ඕනේ. Which means it can be under the impact of a fan, external fan, right? Or any other source of wind using maybe pipe එකකින් එන wind එකක්, air flow එකක්, right? ඔය dry එකකින් එන air flows තියෙන අන්න ඒ වගේ නිකන් air flow එකක් වෙන්න පුළුවන්. ඔක්කොම අර නිකන් fans වගේ එකක් නේ තියෙන්නේ. Right? So if there is something forced, as the word says, that is a forced convection. Natural conditions විතරක් තියෙනවා, that's a natural convection. Right? Okay. Then, right, listen. Now this is valid for larger temperature differences. Larger temperature differences under forced convections only. Under forced convections only. Right? Under forced convections only. Right? So therefore, we are going to have a forced convection here. Right? We are going to have a forced convection. Otherwise, we can 23 limit. Right? It will spread the gun on the graph. So therefore, we will be using a forced convection. And this is how this works. Listen. This is how this works. Right. Materials you better mention this. Right? Take down the theory first. Take down the theory first. Write down law of cooling. Law of cooling clear. After this line, may line clear. Write the first line. Write the first line. Write the first line. Write the first line. And write law of cooling. That's it. In red. Law clear red. Write the law of cooling in red. Rate of heat loss. Rate of heat loss. Rate of heat loss from a heated object. Rate of heat loss from a heated object. Rate of heat loss from a heated object is directly proportional to excess temperature between directly proportional to excess temperature between object and the environment. Excess temperature between object and the environment. Excess temperature between object and the environment. Right. Then write down the equation and introduce terms. Write down the equation and introduce terms. Introduce terms. Rate of heat loss, coefficient of emissivity, area open to atmosphere, excess temperature. Right? Then mention this below. Valid for larger temperature differences under forced convection. Underline or highlight forced convection. Right? Underline or highlight forced convection. Right. Listen now. Right? Listen. Now, rate of heat loss depends on Q over T depends on EA theta minus theta R. No? Right? Now, if I need to control this, first tell me on which E depends on. On which E depends on? On which E depends on as a factor. Come again. Huh? On which coefficient of emissivity depends on? Huh? Nature of the surface. Nature of the surface. Right? Nature of the surface. If nature of the surface is same, E should be same. Right? Then, for the experiment, for the experiment, therefore, we are going to use the same calorimeter. Right? If the same calorimeter is used, right? මේ මුල ටික තමයි තේරෙන්න ඕනේ මේක logic එක. හොඳේ? මේක logic එක තේරුණාට පස්සේ මේ experiment එකේ ඇති දෙයක් නැහැ. Right? If you understood the logic, right, then there's nothing here. Then there's nothing here. Right? To make E constant, nature of the surface should be kept constant. No? Then same calorimeter is going to use, because we are going to do something under two scenarios, right? For water and a liquid. For water and a liquid, right? Then we'll be using the same calorimeter. If same calorimeter is used, we can make sure that same nature of the surface is there, is same, right? And area open to atmosphere can be controlled by filling the liquids up to a same height. By filling the liquids up to a same height. What about? Lock කරයි දන්නේ නැහැ ඔය. Any windows open? Metering in. Right. Listen. Right. Listen. To keep the area open to atmosphere, constant, the liquid is filled, right? Liquids are filled. Liquid scale again, water and liquid are filled to the same height. If it is filled to same height, area open to atmosphere is same. Area open to atmosphere again, that is not only the surface. That is not only the surface. Area open to atmosphere again, may okkoma. Right? Right? When the liquid is like this, assume this has a liquid column, right? All this surface is open to atmosphere. Maybe I think convection, you know, right? Everything is open. Area open to atmosphere again, right? That is the total area of the liquid, right? To keep it constant, right? To keep it constant, it is filled up to the same height. And if we do all the calculations in the same temperature difference, right? Theta minus theta r is also going to be same, right? Then, if whole right-hand side of the equation are constants, E is a constant because same calorimeter is going to use. A is constant because liquid and water are going to fill to the same height, right? And theta minus theta r is constant because we will be doing all calculations in the same temperature range, same temperature difference, right? Then, if all these are constant, then Q over T should be constant, right? So therefore, our argument is this. Now, hence, Q over T should be constant, right? Then, we'll be plotting two cooling curves for water and a liquid, right? For water and a liquid, right? When all these conditions remain constant, then Q over T of water should be equal to Q over T of liquid, right? And finally, we are going to equalize these two, right? Simply, right? First scenario, we are going to cool down, right? We are going to cool down water, right? Say we are starting from 70 degrees Celsius, right? We are starting from 70 to, and say the system is cooled down to 40, right? 35, 30 to 30, right? Then between 70 and 30, all calculations are done, right? Using same calorimeter, filled up to same height. Then rate of heat losses of water, right? Rate of heat loss of water is equal to rate of heat loss of liquid, and we can equalize these two, right? Once these two are equalized, since S of water, specific heat capacity of water is known, specific heat capacity of the other liquid can be determined, right? My equation earlier penna logic, right? If you understood the logic, first part is done, right? If you understood the logic, first part is done, right? Now, therefore, right? Q over T of water plus calorimeter equals Q over T, rate of heat loss of liquid plus calorimeter. Right? Kaimma Q over T dege equal karana then. Right? Now, have to start from here. Right? Mention this again and mention these points with arrows. Mention the equation again and mention these points with arrows. Can I explain the logic again? We'll explain again under methodology, right? Right. First, for E write down, for E write down, same calorimeter is used. Same calorimeter is used. E වලට දාන්න arrow එකක් දාලා යන same calorimeter is used. Right? And for A write down, මේකට arrow එකක් දාලා යන both liquid and water are filled up to same height. Are filled up to same height. Right? For theta minus theta r, write down. All calculations are done. Within same range. Right. Now write this below as a point. Hence, right hand side of the equation remains unchanged. Hence, right hand side of the equation remains unchanged. Right? So that left hand side LHS should be unchanged. Right? Okay, now mention this. Therefore, Q over T of water plus calorimeter equals Q over T of liquid plus calorimeter. Right. Listen now. Right. Now I'm going to explain about the method of the experiment. Listen. Right. My equation to write the equation, we need readings, right? To explain about readings, I have to explain the experiment, right? Listen now. Now, we are using this. This is a stand, right? On the stand, this calorimeter is suspended. On the stand, the calorimeter is suspended, and it is closed using an insulator lid. Right? This is an insulator lid. Right? And styra thermometer. Right? The liquid is filled up to here. We have to make a force convection here to create a force convection. Right? We are using a uniform airflow from a fan. Right? uniform airflow from a fan. Right, a normal table fan napkin. Right. Table or stand or whatever it is, it should be a uniform airflow with the fan. Right. Then throughout the experiment, you have to keep on the fan at a constant speed. Right. Right. Now, what we do is this. Initially, listen now. Initially, before filling this with water or liquid, right? First of all, I need the mass of the system, initial mass. Right? Readings make explain. Right? First one, I need the initial mass. Initial mass empty calorimeter with stirrer. Right? So first of all, I need the mass of, right? Mass of empty calorimeter plus stirrer. Right? Same one. Now, this is filled with water. Right? Water means heated water. Usually we heat it up to 70 degrees Celsius. Right? No rule. 70 usually heat current. 70 or 80. Right? 70 usually. So water is heated up to 70. And water in 70 is put into the calorimeter. Right? Once water is put in, right? Once water is put in, again you have to take the reading, mass of water plus calorimeter plus stirrer, let's say M2. Right? Now, mass of water is known here. Then mass of water is M2 minus M1. Right? Now, system is at 70. System is at 70. 70. System is at 70. And then we let this cool under this force convection. Right? The airflow something known as fan face color. Right? Then under this force convection, we let this cool. Right? And for each 30 seconds, for each 30 seconds, you are going to take the reading of this thermometer. For each 30 seconds. Right? Then in a table, we are going to record the temperatures of thermometer. Right? This is time. Right? Time from 0, 30 seconds. Minutes 0.5, 1, 1.5, 2, 2.5, 2.5, 3. 2.5, 6. Minimum 6 we need. Over. Right? It has a median water. Right? Methana liquid. Right? Now, temperatures are recorded against time. Time temperatures and we are going to plot the cooling curve of water. Right? We are going to plot the cooling curve for water. Listen. Cooling curve is between, what are the axes? Cooling curve. Temperature and time. Theta with time. Right? Theta is in degrees Celsius now. And time in seconds. Right? Time in seconds. Right? Minutes time seconds make mark. Right? Then, say you are starting from 70. Right? The cooling curve until theta R, room temperature. Right? And then after plotting the cooling curve for water is removed from the calorimeter. And this same calorimeter is used again to fill the liquid. Liquid is filled to the same height. Liquid is filled up to the same height and it is heated to same temperature. And once liquid is filled, have to take the mass again. Then mass of liquid plus calorimeter plus stirrer, let's say M3. Then mass of liquid is given by M3 minus M1, right? M3 minus M1. And repeating the same for the liquid. Right? Repeating the same for the liquid. So liquid එකටත් මෙහෙම curve එකක් එයි. Starting from 70. Again, it is also going to cool down to room temperature. Right? The water වලට එකක් අඳිනවා. Liquid එකට එකක් අඳිනවා. Right? And we are going to select, listen, we are going to select the same temperature range. We are going to select at same temperature range. Right? අපි මේ වගේ temperature range එකක් ගමු. මේකට temperature එක say from here to, එතන මේ initial points ගන්න නැහැ. Somewhere from the middle in between. Right? මේවා special points නේ. මෙහෙම range එකක් ගන්නවා. Then during the same range, see මේ graph එක හොඳට බලන්න. During the same range, see water has taken to cool down from say theta 1 to theta 2, to cool down from theta 1 to theta 2, water has taken this much of a time, right? And during the same range, this liquid has taken a time from here to here. Cross say time of liquid, right? Graph now we are going back to our logic, right? Logic QOT of order, right? Maybe they know again experiment QOT of order plus calorimeter equals QOT of liquid plus calorimeter, right? Mega plug karna. Then for water and calorimeter, mass of water M2 minus M1, right? M2 minus M1, right? Let's assume specific heat capacity of water as CW, right? Temperature difference is same for water and calorimeter. No? Going to take it out, right? Plus calorimeter part mass of calorimeter is M1. Then temperature difference theta 1 minus theta 2, right? Over water TW, right? Equals mega same තමයි කරන්න තියෙන්නේ මම පොඩියට ලියනවා. Then for liquid M3 minus M1, say C liquid Cl plus M1 again, and the temperature difference is same theta 1 minus theta 2 over time TL, right? These two are going to cancel, and from the rest M1 is known, M2 is known, M1, M2, M3 are known, TW, TL are known, right? And we know the standard value of specific heat capacity of water. Then using the calculation, CL can be determined, right? Difference between the previous method and this one is, previous one was for a solid, right? This is for a liquid, right? For liquids, this is the only method we have, right? Liquids වල කලින් එකෙන් හොයන්නත් පුළුවන්. හැබැයි ඒක අපිට ගයිඩ් දෙන්නේ නැහැ. මේක තමයි අපිට liquids වල තියෙන්නේ, and this is the only experiment from Newton's law of cooling. Only experiment we have from Newton's law of cooling, right? Okay, right. මේක theory එක explain කරන්න යද්දි ඉතින් ඔක්කොම ටික කියන්න යනවා නැත්තම් තේරෙන්නේ නැහැ. දැන් theory එක මේක ඇත්තටම මේක තමයි theory එක. ඉතින් මේක වට කිව්වට තේරෙන්නේ නැහැ, right? නැත්තම් theory එකට එන්න මෙච්චරයි, right? Now where did we stop? Right. Then mention about the readings, right? Write down readings. Readings එක ලියන්න. අනිත් ටික ඔක්කොම method එකේ ලියන්න. Write down the readings. Right, mention the readings. Write down. First one, mass of empty calorimeter. Mass of empty calorimeter with stirrer within brackets M1. Mass of empty calorimeter with stirrer within brackets M1, right? Second one, mass of water calorimeter with stirrer mass of water, comma, calorimeter with styrer. Right? M2 within brackets M2. Right? Next one, mass of liquid, mass of liquid, mass of liquid, mass of liquid, comma, calorimeter with styrer. Mass of liquid, comma, calorimeter with styrer. M3. Right? Next one, time taken by water to cool down. Time taken by water to cool down. Time taken by water to cool down from theta 1 to theta 2. Time taken by water to cool down from theta 1 to theta 2. Time taken by water to cool down from theta 1 to theta 2. Right? Within brackets TW. TW. By क्या कहोगे? TW. Right, next one. Time taken by liquid. Time taken by liquid. Time taken by liquid to cool down from theta 1 to theta 2. Time taken by liquid to cool down from theta 1 to theta 2. Within brackets TL. Right, then specific heat capacity of next one. मैं तेरा comment में mention करूँ. Specific heat capacity of water. CW. Specific heat capacity of water. CW. Specific heat capacity of water. CW. Next one, specific heat capacity of liquid. Specific heat capacity of liquid. CL. Specific heat capacity of liquid. CL. Fine. Next, specific heat capacity of calorimeter. Specific heat capacity of calorimeter. C L. Sorry, CL में CS. Right? को में तो निकली L ने M1 CS. Right? Okay. Then write down below. According to the theory, put a comma. According to the theory, put a comma and mention this. QOT of water plus calorimeter equals QOT of liquid plus calorimeter and mention the equation. Right? M2 minus M1 mass of water into CW specific heat capacity of water plus M1 CS mass of calorimeter times specific heat capacity of calorimeter, whole thing into temperature difference theta 1 minus theta 2. Right? Over time it takes TW. Same thing on the other side. For liquid, mass of liquid is M3 minus M1, right? Into specific heat capacity of liquid CL plus calorimeter M1 into CS brackets theta 1 minus theta 2 over TL. Nah, දැන් graph එකයි මේ වගේ අඳින්න එපා. tables නුකුත් ලියන්නත් එපා. right? graph එක ඇඳෙන්නේ නැත්නම් මේක explain කරගන්න විදියක් නැති ඉන්න. right. Then write down below. CL can be determined using the equation. CL can be determined using the equation. Cl can be determined using the equation. Right? Cl can be made Cl can be determined using the equation. Equation can make it using this equation. Cl can be determined using this equation. Right? Alright. Then තමයි theory එක ඉවරයි. Right? theory එක ඉවරයි කියන්නේ අතන experiment එකේ ඔක්කොම ටික වගේ ඉවරයි. Right? දැන් අර ඔඩේකට අපි මේ කරගෙන යනවා. Right. Next, write down materials and apparatus. Materials and apparatus. Materials and apparatus. Right. Write down. First one, a polished calorimeter. A polished calorimeter. Right? Now, when I say polished, now you know what the reason is. A polished calorimeter. Right? Next. A heat insulated lid. A heat insulated lid. A heat insulated lid. Thermometer, styrer. Thermometer, styrer. Stand, stand. Right? Near the stand there. Stand. Stand. Right? Then an electric fan. An electric fan. An electric fan. Right? අනිත් ඒවාට ඉතින් අපිට විතර measure කරගන්න ඕනේ වුණේ ඒවා. Right? We are measuring masses. Right? Then triple beam balance, four beam balance, or electronic balance. Right? Either one. Triple beam balance, four beam balance, or electronic balance. Triple beam balance, four beam balance, or electronic balance. Right? Then time is measure කරගන්න ඕනේ. To measure times, stopwatch. A stopwatch. A stopwatch. Right? Then finally, sufficient amounts of water and liquid. Sufficient amounts of water and liquid. Sufficient amounts of water and liquid. Right, now take down the diagram. Take down the diagram. මේක විතරයි. Take down the diagram. Right? Right, take down the diagram. Diagram. डायग्राम में कॉलिंग एक्सपेरिमेंट है टेबल ना है टेबल रखना कॉलिंग है टेबल रखना right the table ले आने पा only the diagram करना okay write down the method write down method first point measure the mass of measure the mass of measure the mass of measure the mass of empty calorimeter with stirrer measure the mass of empty calorimeter with stirrer right next point fill water up to fill water up to a certain height fill water up to a certain height within brackets within brackets within brackets 1 centimeter less 1 centimeter 1 centimeter less than total height 1 centimeter less than total height less than total height to fix the lid to fix the lid right again මෙහෙමයි 1 centimeter කියලා rule එකක් නෑ if the lid is 1 centimeter lid is around 1 centimeter usually right lid එකේ තියෙන space එක අයින් කරලා අපි තියනවා නැත්නම් lid එක ගන්න බැරි වෙනවා right when water is put in right ඒතර එහෙම rule එකක් නෑ 2 centimeters තිබ්බත් කමක් නෑ lid එක තියෙන 1 centimeter උනාට doesn't matter unless we fill the liquid and the water to the same height doesn't matter right අර okay issue එකක් එන්නේ issue arises if you fill it up to the surface and try to close the lid right ඒතකොට lid එක වහන්න බෑ right measure කරන්න කියලා කිව්වේ නෑනේ right and measure mass of system and measure mass of system within brackets m2 and measure mass of system within brackets m2 and measure mass of system within brackets m2 right next point next point start recording temperature of water start recording temperature of water in each 30 seconds in each 30 seconds when it cools down when it cools down Next point. Plot the cooling curve. Plot the cooling curve. Plot the cooling curve. Plot the cooling curve for water. Plot the cooling curve for water. Plot the cooling curve for water. Right. Next. Remove water from calorimeter. Remove water from calorimeter. Remove water from calorimeter and fill it. And fill it. Remove water from calorimeter and fill it with the liquid. And fill it with the liquid up to the same height. Up to the same height. And fill it with the liquid up to the same height. And measure the mass of and measure the mass of liquid comma calorimeter with stirrer. Liquid comma calorimeter with stirrer within brackets M3. Within brackets M3. Right? Within brackets M3. Repeat the same. Next point. Repeat the same procedure. Repeat the same procedure. Repeat the same procedure. Repeat the same procedure for liquid and plot the cooling curve. Repeat the same procedure for liquid and plot the cooling curve. And plot the cooling curve. And plot the cooling curve for liquid on the same axis. And plot the cooling curve for liquid on the same axis. And plot the cooling curve for liquid on the same axis. Right? Right. Next point. Next point. All data are recorded. Next point. All data are recorded. All data are recorded in the following table. 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 To plot cooling curves. To plot cooling curves. Right. Copy down the table. Right. This is time. Right. Time. And it is in minutes. Right. Minutes. Time in minutes. It has made the temperature of water. Right. Second one. Temperature of water. Temperature of water. And this is temperature of liquid. Temperature of water and temperature of liquid. Temperature of water and temperature of liquid. Temperature of water and temperature of liquid. Temperature of liquid. Right, take down the table. Right, 0.5, 1, 1.5, 2, 2.5. right ඊට පස්සේ graph එක. Now below the table take down the graph pooling curves. Then take down the graphs. Sorry. This one is for water. This one is for water. This is the liquid. $70 within theta r, theta 1, theta 2. And from theta 1 to theta 2, mention these times probably. Time takes by water is Tw, by liquid is Tl. Right. Alright. Done. Done. Double check the graph. Graph එක තමයි මෙතනින් important මේක. Double check the graph. Graph එකේ times ටිකයි temperatures ටිකයි double check කරන්න. Right? Axis, times and temperatures. Right. Now calculation. ඊළඟ දාගන්න calculation කියලා. Calculation. Right. See, for water, right? For water, listen. For water, now Q over T of water. Q over T of water කියලා කියන්නේ water plus calorimeter. Right? Mass of water is M2 minus M1. Mass of water is M2 minus M1. Specific heat capacity of water is Cw, right? And mass of calorimeter was M1. Specific heat capacity was Cs, right? And they are cooling down from theta 1 to theta 2 during a period of Tw. Right? Q over T of water plus calorimeter. Alright? Total heat should be here. Then heat liberated by water is here. Heat liberated by calorimeter is here over their time Tw. Alright? Then same thing for liquid. Same thing for liquid. Q over T of, right, water plus liquid. Same thing. M3 minus M1, mass of liquid, times C of liquid plus calorimeter M1 CS. Same temperature difference, theta 1 minus theta 2, right? Over a period of or time interval of TL. right? Mention these two. Further. Right? Write down. Label this. Label this as equation 1. Label this as equation 2. Write down. According to theory, according to theory, 1 equals 2. According to theory, 1 equals 2. Right? Equalize these two. According to theory, 1 equals 2. Then theta 1 minus theta 2, theta 1 minus theta 2 is going to cancel, and the rest remains, right? M2 minus M1 plus M1, sorry, CW plus M1 CS, M1 CS over TW equals M3 minus M1, M3 minus M1 CL plus M1 CS over TL. Right? Write down below again. Calculate CL, calculate CL, calculate CL, calculate CL using calculate CL using standard values for using standard values for using standard values for CW and CS, CW and CS using standard values for CW and CS. Right? Okay, so basically experiment is done from here. Right? Remarks are there are special things. Right? Any questions about the experiment so far before going on to remarks? Any questions? All good? Right? Right, remarks right. Go to remarks. Go to remarks. Go to remarks. First point. First point. First point. Both water and liquid. First point. Both water and liquid. Both water and liquid. Both water and liquid should be filled up to. Should be filled up to. Should be filled up to same height. 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 Within brackets, within brackets, within brackets, same point within brackets. To make areas open to atmosphere equal. To make areas open to atmosphere equal. Right. Next point. Same calorimeter should be used. Same calorimeter should be used. Same calorimeter should be used for both water and liquid. Same calorimeter should be used for both water and liquid. Same calorimeter should be used for both water and liquid. Within brackets, to equalize nature of surface. 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 Then all calculations, next point, all calculations should be done. All calculations should be done within the same temperature difference. All calculations should be done within the same temperature difference. All calculations should be done within the same temperature difference. All calculations should be done within the same temperature difference. Within brackets, equalize excess temperature. Equalize excess temperature. Right. Next point. Both water and liquid should be well stirred. Both water and liquid should be well stirred. Both water and liquid should be well stirred throughout the experiment. To ensure uniform distribution of temperature throughout. To ensure uniform distribution of temperature throughout. To ensure uniform distribution of temperature throughout. Right. Next point. To ensure uniform distribution of temperature throughout. Next point. Glass or plastic calorimeters. Glass or plastic calorimeters. Glass or plastic calorimeters are not used. Right. Reason is this. Listen. When it comes to glass and plastic, right? Copper use calorimeter is copper, right? What we are using is copper, right? Glass and plastic use because glass and plastic are heat insulators, right? They are weak heat conductors. Heat insulators they are weak heat conductors, right? Then it takes a long time. To cool down, right? So when it takes a long time to cool, temperature outside the calorimeter, listen, temperature outside the calorimeter is different from temperature inside the calorimeter. Then temperature outside the calorimeter and temperature of the liquid are two different values, right? Right? Issue because outside temperature is room temperature. It matters to make these conditions constant, unchanged, right? That's the thing. Alright, write down within brackets. Since they are weak heat conductors, temperature of calorimeter temperature of calorimeter can be different from temperature of liquid. Temperature of calorimeter can be different from temperature of liquid. Right? Right. එහෙම වුණොත් මේ equations ඔක්කොම ටික වෙනස් වෙනවද කියන්නේ කරන්න බැරි වෙනවා because I have considered a same temperature difference for both liquid and the calorimeter. Theta 1 minus theta 2. Now if these two are two different temperatures, right? If these two are two different temperatures, even I can't write this equation. එහෙම ලියන්නත් බෑ. Right. That's it. Right? So quickly go through what is given. Compare the value of obtained experiment with the standard value of the specific capacity of liquid for the ideas also. Right. Right. The other thing, the last thing, listen. Listen. Now, when we take the temperature difference from this point to here, right? When we take the temperature difference from theta 1 to theta 2, right? Theta 1 to theta 2, right? During the range, right? In the range, there can be amount of heat loss to environment, right? ඒක නැති කරන්න බෑනේ. පොඩි හරි amount එකක් loss වෙනවා, right? To eliminate this and to get more accurate reading, right? We can do the calculation like this, right? If we consider only one point here and find the gradient, if you find the gradient of a single point, may gradient එක හොයාගන්න මේ point එක. Right? If you are finding the gradient of a curve, we have to use a mirror strip. දන්නවනේ? Mirror strip එක use කරන method එක දන්නවද? Right? Mirror strip එක use කරලා හොයාගන්න ඕනේ මේක කරනවා නම්. Right? Mirror strip එක use කරලා කරන්න මෙහෙමයි. Right? If you need to find the gradient here, right? Say I need to find the gradient of this point. Right? Point එකේ gradient එක. Because gradient changes over the line. Right? If you need to find the gradient of this one, right? What we do is have to keep a mirror, right? Mirror strip on the line like this, right? Have to keep a mirror strip on the line like this, right? And we will see the image of this curve on the mirror, no? Right? You will see the image of the curve on the mirror, right? Make a podi mirror strip එකක් මහත්තුනොත් කරන්න බෑ. A small mirror strip, and you have to rotate the strip until the actual curve and the image that you see from the mirror are coincided. When they are coincided, right, which means this point is collinear, no? When මේ point එක collinear. Now if you draw a line here, if you construct a line here, that is exactly a perpendicular line drawn to this point. Then remove the mirror and draw another perpendicular line to this, and this is the correct gradient, right? නැත්නම් curve එක හොයන්න බෑ, right? ඒකත් එකක්. If you are going to this method, have to use a mirror strip to find the gradient. That is not as easy as finding the gradient of a straight line. Now y minus x delta y minus delta x එහෙම ගන්න බෑ, right? Point එකෙන් point එකට change වෙනවා. Then only method we have is using a mirror strip, right? මේකත් mention කරලා වැඩේ ඉවර කරමු. Right, මේ තියෙන mirror strip එක. Write down as the next point. To have more accurate value, for Cl, temperature difference can be written temperature difference can be written. Temperature difference can be written what is it? Can be written using gradient of graph. Using gradient of graph. Using gradient of graph as follows. Using gradient of graph as follows. Using gradient of graph as follows. Right. This is a magnified view of this, right? And now let's say this angle is alpha. Gradient is tan alpha. Correct? Angle is alpha. Gradient is tan alpha. What is given by the gradient here from the graph? What is given by the gradient of the graph? This is a cooling curve. What is given by the gradient of the graph? Gradient. What is given by the gradient? Delta theta over delta t, right? Then what is it? As a variable or as a quantity? Rate of cooling, right? Not rate of heat loss. Q over T, rate of cooling. Rate of cooling. Oh, that is also called rate of temperature fall. Right? Rate of cooling and rate of temperature fall. Right? They are very small values now. We are going to take the gradient at a point. For very small values, we are using differentiation. Right? Or differentiation use karna addition. Then you are using differentiation. Then this is delta theta or delta t. Right? Then instead we will be writing d theta or dt. I think differentiation part. Right? And this is the tan alpha now. This is tan alpha now. Right? With the delta a very small difference. Because that's a value at a point. Tan alpha. Right? Maybe there are now when you are writing the temperature fall here, delta theta or t part, then this part can be replaced by this. Right? Take care of curve. Plot the curve and this of method that explain mirror strip use karni. Okay, finish. Gradient is dt theta over dt tan alpha. Right? So what we are going to measure is tan alpha. Tan alpha is equivalent to d theta over dt. Right? Now, this is what we do. Mirror strip use karni de kiyan nang right? Now, if we do the same for both water and liquid, right, you will get two gradients, no? Right? Then curves curve. So likewise, if you repeat the same for the next curve also, right, we'll get something like this. Right? Now, if you do the same for water and liquid, if you do the same for water and liquid, right? From here, we can get d theta over dt of water. Say that is tan alpha 1. And from here, you can get d theta over dt of liquid. Say that is tan alpha 2. Right? Now, since all other conditions are same, Q over T should be same. Right? Our logic को use करना. Since all other conditions are same, Q over T should be same. Right? Then Q over T of water equals Q over T of liquid. Right? අර වැඩේම කරනවා. Right? For theta over T, we will be writing this one instead. Right? මේක ලියන්න නෑ දැන්. අර time durations ඕනෙත් නෑ. Time duration එක ඕනෙත් නෑ. හරි? මේවා මොකුත් ඕනේ නෑ. කෙලින්ම දැන් මේක ලියන්න. Like this. Total heat is M2 minus M1 CW M1 CS. මෙන්න මෙතෙන් temperature fall එක එන්න ඕනේ. Right? මේ theta over T part එක replace කරන්න යන්නේ නේද? වැඩ තේරෙනවද? That is into tan alpha 1. Tan alpha 1. Right? ඊට මගනේ මම මේ ලියනවා. මේක erase කරනවා. මම මේක තිබ්බේ නිකන් compare කරගන්න ඉඳලා. Right. කවන්න එකක් තියන්න. Right. See? Then Q over T of water equals Q over T of liquid. Q over T of water කියලා කියන්නේ M2 minus M1 CW plus M1 CS. Right. මෙන්න මෙතෙන්ට එන theta over T එකක් තියෙනවනේ. That is theta over T delta theta over delta T or dt d theta over dt of water. Right? Tan alpha 1. හරි? හරිද? මේ එන්නේ මේක d theta over dt of water. Right? කාන මේක ලියලියනම් theta over t එක replace කරාම then here m3 minus m1 cw m1 cs, right? m1 cs d theta over dt of liquid. Right? Then this is tan alpha 1, right? This is tan alpha 2. Right? Tan alpha 1 and tan alpha 2 are known from gradients, right? Then again, can do a simplification. This is a little bit more accurate because you are not doing a calculation for a range. Range එක කරන්නේ නැහැ. Right? This calculation only at a point. Right? Point එකේ විතරයි වැඩේ කරලා තියෙන්නේ. Range එක කරන්නේ නැහැ. එහෙම කරන්නත් පුළුවන්. Right? Okay. Now take it down. මේක ලියුවත් නෑ නේද? Now apply this for these two and show it and write this. Right? Understood? Right? That's it. මේ මිරේක use කරන විදිහ කියන්න ඕනද? මතකයි? දැන් මතකයි පස්සේ අමතක වෙයිද දන්නේ. කවන්න එකක් ලියාගන්නකො. නැත්තම් මිරේක අමතක වෙලා මාව මතක් වුණොත්. ඕකක් ඇවිල්ලා. Right. Write down. Use a mirror strip. Use a mirror strip to find. Use a mirror strip to find. Use a mirror strip. Use a mirror strip to find. Use a mirror strip to find gradient of a curve. Use a mirror strip to find gradient of curve. Right. Write down. Keep a mirror strip. Steps wise किया ना 1 2 3 डाल लिया है. First one. Keep a mirror strip. Keep a mirror strip. Keep a mirror strip. Keep a mirror strip. Keep a mirror strip on the curve. Keep a mirror strip on the curve. Keep a mirror strip on the curve and rotate it and rotate it and rotate it until and rotate it until reflected image of curve at the point, reflected image of curve at the point coincides with actual curve. Coincides with actual curve. Draw line. Second step wise जाना. Draw line along the mirror at this instance. Draw line along the mirror at this instance. Within brackets, this is a normal drawn to curve at this point. This is a normal drawn to curve at this point. This is a normal drawn to curve at this point. This is a normal drawn to curve at this point. This is a normal drawn to curve at this point. Right. Next step, remove the mirror. Remove the mirror. Remove the mirror strip. Mirror strip. And construct a normal to the previous line and construct a normal to the previous line and construct a normal to the previous line. Right? Within brackets, this line is the tangent drawn. This line is the tangent drawn to the curve at the point. This line is a tangent drawn to the curve at the point. This line is the tangent drawn to the curve at the point. Right? ඇතිනේ. ඒතර gradient එක හොයාගන්න ඕන නම් ඉතින් complete the triangle and measure the angle. That's it. එකත් ඕන නම් ලියා ගන්න. Complete the triangle and measure the angle tan alpha. Right? Tangent එක ඇඳගත්තා කියන්නේ හරි. Because otherwise the thing is right මේක එහෙනම් critical නේද? ඒ කියන්නේ මේක you know just by keeping a ruler like this, right? We can't see whether it is exactly tangential or not by the unaided eye. මෙහෙම නිකන් බලන්න බෑ. පොඩ්ඩක් වෙනස් වුණා කියලා ඒක තේරෙන්නේ නැහැ. That's the thing. ඒකයි mirror strip එක use කරන්නේ. මේකෙන් එන එක හරියටම හරි. right? තේරෙනවද? ඒ කියන්නේ නිකන් rule එකක් තියලා මෙහෙම rotate කරලා අපිට බලන්න බෑ. You can't say whether this is tangential, this one is tangential. එහෙම කියන්න බෑ. right? ඒක වෙනස් වෙනවා. ඒක පේන්නේ නැහැ නිකන්. තියලා බලන්න rule එකක්. මෙහෙම curve එකක් ඇඳලා point එකක් ගාලා මෙතන rule එකක් තියලා බලන්න. එහෙම කරන්න බෑ. right? That's why we have this method as a more accurate method. Right? Okay, that's it. That's everything. Any questions? Oh. Same theory ගන්න ඕනෙත් නෑ දැන්. ඇයි? මේ දෙක දන්නවද? That's a good question. Listen. Listen. Now, listen. When you take, listen. Same theta ඕනේ. ඔයාගේ same theta ද කියලානේ. difference එකක් වැඩක් නැහැ. Right? Same theta. Yes. Yes. Same theta කියන එක හරි. Because go back to our fundamentals. We have kept theta minus theta are constant because theta is constant. No? Then theta should be constant. හරිනේ? ඒකෙන් එතනින් difference එකක් නැහැ. Right? මෙතනනේ දැන් point එක තියෙන්නේ theta minus theta r should be constant. දැන් theta කියලා කියන්නේ temperature at this point. Temperature of the object at this point. Right? It should be constant. නැත්නම් මේක වෙනස් වෙනවා. Right? එතකොට මේ curve එක මෙතන ඇන්දොත් මෙහෙම නෙන්නේ. මෙහෙම curve එක නෝනේ. මෙතනින් ගන්න ඕනේ. theta නම් theta කියන්නේ මෙතනින්ම ගන්න ඕනේ. Right? That's a good question. Listen again. Our initial assumption was assumption කියලා කියන්නේ that is one of our initial conditions we kept constant. Otherwise, if right hand side is different, I can't argue this. Right? මේක argue කරන්න බෑ. Right? ඒ හින්දා මේ වැඩේ කරත් theta should be constant. මේ theta should be same. Theta should be same. Difference කතාවක් නැහැ. Theta should be same. theta එක විතරක් same වෙන්න ඕනේ. හරිනේ? අරගෙන නම් difference එකම same වෙන්න ඕනේ. මේක theta විතරක් same වෙන්න ඕනේ. Right? What else? Right, මේක හරිනේ. හරි. What else? Any other questions? No? Inesi ke questions තියෙනවද? Anything? No? ඉතින් මොකද සීදල? යනු කාටද? Online? Can you explain the logic again? Logic එක දැන් හරින්නේ? Logic එක අහලා තිබ්බ logic එක හරියන්නේ නැන්නේ? L plus C for liquid in equation. Yes, liquid. Liquid plus calorimeter. Oh, good for now. Can you slow down your telling speed when points are ready? Right.